Okay, in this video we're going to talk about periodic functions, and we're going to talk about them in terms of the world's largest Ferris wheel, which is called the London Eye, and there's a picture of it in your notes there. And this Ferris wheel is 450 feet in diameter, and it completes a full rotation once every 30 minutes, and apparently that is slow enough so that you can climb on the Ferris wheel down here at the bottom without the Ferris wheel ever actually stopping. So what we want to do is we want to fill in this table of values. We want to know how high would you be off the ground if you climb on the Ferris wheel here at the bottom. How high would you be off the ground after 0 minutes, 7.5 minutes, 15 minutes, and so on. So we're going to fill in this table with these values. So at time t equals 0, that's when you get on the Ferris wheel right here. So your height off the ground is just going to be 0 there. Now, since I know that the Ferris wheel it completes one full rotation every 30 minutes, well, if you get on here at time t equals 0, well, you're going to go around this direction. We're going in this direction. So you're going to go around this direction, and after 30 minutes, you're going to be back down here at the ground where you started. So after 30 minutes, your height off the ground is again going to be 0. And if you stay on for another rotation, then after 30 more minutes, that is at t equals 60 minutes, you're going to again be down here at your ground level. All right, so I know those values are going to be 0. You'll be 0 feet off the ground each time. And let's see, if it makes one full rotation in 30 minutes, then that means it must make a half a rotation in 15 minutes, which means after 15 minutes, you're going to be up here at the top of the Ferris wheel. And if the Ferris wheel has a diameter of 450 feet, then that means that your height off the ground is going to be 450 feet. So after 15 minutes, you'd be 450 feet off the ground. And then you'd keep going, and then you'd get down here to the bottom again at 30 minutes. And again, if you stayed on for another rotation, then another 15 minutes after that, that is at 45 minutes, you're again going to be up at the top of the Ferris wheel, which means you would be 450 feet off the ground. Remember, 450 feet is the diameter of the Ferris wheel. All right, so now we just have to fill in the rest of these. So this is after 15 minutes. We know we're at the top. So after 7.5 minutes, which is halfway between 0 and 15, well, after 7.5 minutes, you must have gone up to this point right here. So after 7.5 minutes, you'd be sitting right here on the Ferris wheel, and I can see that that height off the ground is going to be the same as this distance here. That is, it's going to be essentially the radius of the Ferris wheel. Well, the diameter is 450 feet, then the radius must be half of that, which would be 225 feet. So after 7.5 minutes, you'd be at this point right here, and you'd be 225 feet off the ground. You'd keep going up to here, where you're 450 feet off the ground. Then you'd start coming down, and after 22.5 minutes, that is halfway between 15 minutes and 30 minutes, you'd be right here, which again is 225 feet off the ground. Then you'd come back here to the ground level. You'd be 0 feet off the ground after 30 minutes. You'd start back up, and another 7.5 minutes after that, that is at 37.5 minutes, you'd again be 225 feet off the ground. Then you'd keep going another 7.5 minutes. That would put you back up at the top again at 450 feet. Another 7.5 minutes would again bring you to this point, and again you'd be 225 feet off the ground. And we could keep going, but you can start to see you're just going to be the same. It's just going to keep repeating the same values here. That's why we call it periodic. Okay, so now we have all these values in our table. Well, now what we want to do is we want to graph what these values are going to look like. So here's this set of axes. I've got t for my independent variable, and I've got f of t for my dependent variable. Well, let's graph these points here. So let's see, I'm going to be going from my independent variable is going to go from 0 to 60. So let's see. I'm at 60 over here. 30 is going to be in the middle. And let's see, so 15 will be here, and that's going to be 45. Here's 7.5, and between 15 and 30 is 22.5, and between 30 and 45 is 37.5, And between 45 and 60 is 52.5. All right, so now let me see, what do I want my dependent variables to be, or my values to be? So let's see, I'm going to be going from 0, that's the lowest point that I get on this axis. And the highest point I get is at 450 feet. That's when I'm up at the top of the Ferris wheel. So I'm going to go from 0 to, let's put 450 feet right here. And so then right there in the middle is going to be 225 feet. Okay, so now I can plot my points. 0, 0, that's this point right here. X is 7.5, Y is 225, so that's right here. Let's see, when t equals 15, f of t is 450, so that's right here. 22.5, I'm back here at 225 feet. T equals 30, I'm back here at 0. T equals 37.5, I'm back up to 225. T equals 45, I'm back up to 450. 52.5, and I'm back down to 225. And t equals 60, I'm back at 0. So I can see my graph here is just kind of, it's representing, in a picture, what I already know is happening. That is, I'm going up, and then I'm coming down, back to the ground. I'm going up, and then I'm coming back down to the ground. And if I were to connect up these points, it's tempting to say, well, let me just connect these up with a straight line. But actually, what this graph would look like is more of a curve that looks kind of like that. And this is a curve that many of you have seen before. It actually looks something like a sine curve, and in fact that's what it is. Now, there's a couple of things we want to note about this particular curve. One is, notice that the amount of time that it takes to make one full revolution around the Ferris wheel, that's this distance here, or this distance in time, this interval of time. I start here at 0, and I'm back to 0. I start here at 0, and I'm back to 0. That distance, that interval of time, that's called a period. In other words, the amount of time it takes to complete one full cycle, that's called a period. We also have, notice that this value right here, these values here are in the middle. 225, we keep going, every time we go up, we pass that middle value, we pass it going down. That middle part, if we draw a dotted line here between all those midpoints, this dotted line here is called the midline. And this midline is just a horizontal line that's in between the maximum value of the function and the minimum value of the function. Finally, we have this value here, which is the distance between the midline and the function's maximum value, and this distance is called an amplitude. So let's go ahead and define these three terms: period, midline, and amplitude. The period is just the time interval during which a function completes one full cycle. The midline is just the horizontal line midway between the function's maximum and minimum values. And the amplitude is the vertical distance between the midline and the maximum or the minimum value. So for this particular function, this particular periodic function, we can actually say what the values of the period, the midline, and the amplitude are. I can see that the period for this function, I already know it makes one full revolution in 30 minutes, so my period is 30 minutes. I can also see that my midline, since my midline is right here at 225 feet, you can see that the midline for this particular function is 225 feet. The amplitude is just the distance between the midline and this maximum value, and again I can see that it's going to be 450 minus 225, which for this function is also 225 feet. Now obviously these particular values depend on, one, how fast the Ferris wheel is going, because that's going to affect the period. That's going to affect how fast you go up and down around the circle. And those values also depend on the diameter of the circle, how big the Ferris wheel is. Because if the Ferris wheel is bigger, well then you're going to be higher off the ground, and that's going to affect the midline as well. So in example number 1 there, you can see that you've got some more questions, A, B, and C, that asks, how would these values change if some different properties of the Ferris wheel were to change? And I'm going to leave you to think about those and fill in those values, and we'll take a look at those tomorrow in class.